I was saying about the Evgenia, sorry. So I will upload the lesson that was like last week. I'll do it today, maximum tomorrow. Yeah. Today we are working with files, so now I'm like covering the part about why should we use read or read line one over another one. So the idea is that if you have like a very huge, let's say, text file, it could be 20 gigabytes, right? And in your case, on your machine, you have 16 gigabytes of RAM. And when you write read, you try to read the object and put it to the RAM. And in this case, you will have the memory overflow because you're trying to put the object which is like larger in size than the other one. And you will have the problem. But in case if you read line by line, you will be okay. So you will read it and everything will work perfectly. And this is a way to go in case of the huge files. And sometimes, especially in bioinformatics, you'll face with some text files which are like super large, and you don't want to try to read them at once. And this is an example about of the read line, how it works. Let's just try to read some lines by using the read line method. So line 1 is int f read line. Read line, and now I want to print, let's print line 1, and also let's print the representation of the line 1. So there is a function wrapper which returns the representation of the file. And in our case, so you can see what's happened, right? When I read the line, by default, I also read the last character inside of the line, which is a new line symbol. And because of that, you can see I got a new line here. And also we can double check it by using the representation method. So here we got the row string from our line. And you can see that in the end we have a new line symbol. And to avoid it, in case if you want to have the line without the new line symbol in the end, you can use the strip method. And in this case, it will try to remove new line symbol from the left right side. Now you can see that we have a line without a new line symbol in it. Okay. And now, yeah, so this is basically the same about that we can read the lines. But also what is nice, that you can read the line using the loops. Why it works? Because file object has the specific functionality which provides us the opportunity to use it as an iterable object and go line by line through each line inside of the file. So, and this is how it looks. You need to write for line in, provide the name of the file that you are using. In our case, it's impf variable. And then here we read the whole file line by line. Let's execute it. And here you can see, so current line is it never ceases to amaze me. We all love ourselves more than other people, but, and this is basically what we got. Here also I want to highlight the one thing. When we read the line, basically our pointer inside of the file went from the first line to the second one, and it means that you have some pointer inside of the file, and it remembers where you stopped in the file. And let's try to do something like that. So line 2 is int f. I want just to copy this part. Then we want to have line 3 is impf, and let's try to add one more. So line 4 is yeah, and let's print all of them. So I want to print line 1, line 2, line 3, line 4. And separator, I will use a new line sample as a separator. So let's run it. And you can see, so we have 4 objects, right? And in case if we print the representation of line 4, you see that it's like empty, it's nothing. So basically we read the whole file, and it doesn't matter how many times we will try to read the new line, we will not read anything because the file was finished. We read it fully in our first example. And here we use just like for loop. Yeah, so here is an example about the advantages of the using the for loop, that you can go line by line. You don't need like to implement yourself any type of the conditional statements to check whether you still reading something or you finished the file. You can just use the for loop, and in this case you will go like through the whole file, and in case if it's like very huge, let's say that you have like million of lines, you will go through each one, and you then can perform any type of operations that you want to perform. So now we know how to read the text files, right? But let's check how can we write to them. Also, I want to say to you that by default, the mode that we are trying to use when we open the file is a reading mode. So that means that you can avoid writing explicitly R every time when you want to read the file. But it's not the case with the writing. If we want to write the file, we need to specify W as a mode for our open function. And this is an example. Let's create a new file. It's write example.py. And here we have our program. So there is a text that we want to put inside of the file. The syntax is very similar. So we use the with statement, then open. We provide the relative path here for the file that we want to create, because we are using the write mode. And then we are using the write method of out.f. We just provide the text that we want to include to our file. So let's execute it. I just want to show you that I don't have a out.txt right now inside of the current working directory. I just used ls. But now I want to run the program. So program is finished. And now if I check ls again, now out.txt is here. And we can even try to check what is inside of the out.txt. So I use just cat command in the Linux terminal. And here we have our file that we created it. We added some quote to our file. Okay, pretty simple in my mind. Yeah. Yeah. So now we want to do the following one. So this is our file. And in case if you try to open and write to existing file using the W, so right now we have our file. So this is a file, right? Now in case if I open write one more time .py. And now I want to just like with open out.txt write mode as out.f. Let's do out.f write one more line added after words. So something like that. Let's execute it. And now let's check cat out.txt. And you can see so that the previous content was erased. So, and this is a very important thing to remember, that if you using the open with write mode, and if you perform something with the file, the previous content will be deleted. So this is a nature of the writing mode. It creates or opens the file, and it like remove the whole content that it was specified before, and then puts a new one. And in case if you want to add something to the file, append, you can use the A mode to accomplish it. So let's copy this example. I will create a new file. I'll call it like append example.py. Here we have our program again, but now we are using the A mode. Let's execute it. And now when I check cat out.txt, you can see that we have from our previous execution one more line added afterwards, but then we used append method to append a new content to the file, and we did not delete the previous one. Okay. So guys, that's it for files. It's like just very basics about files. In case if you have any questions, then please ask. Otherwise, we will switch to the next topic. Okay, no questions. And now we are going to the very, very fun part, or very important part. Yeah, it's object-oriented programming, and we will cover classes. So guys, okay, maybe someone already heard about object-oriented programming before. Do we have such people? Right? Okay, Dastan, can you tell us a little bit? So what do you think about what it is, and is it cool or not? Is it fun for you?
I tend to agree with the extra position on object-oriented programming.
Okay, and so what's the point about that?
There are only two ways to write programs, using functional programming and the wrong one.
So you're like on the side of the functions.
Sort of, but yeah. Typically nowadays a lot of languages are using object-oriented programming almost for everything. So it's very important to know everything this.
Okay. So one opinion, guys. Maybe someone also heard about classes, objects. No. Evgenia, so do you know about them? Can you share your opinion?
No, I didn't, so I can't share.
Okay. So, okay, then I'll try to be on the other side. So Dastan is like, okay, this is a bullshit. We should not use object-oriented programming, but I'll try to be on the other side. I mean, it's not so I'm not saying that I'm using object-oriented programming all the time in my particular programs. If you be honest, yeah, I'm mostly writing functions because it's more of the code that I need to provide usually, especially in my cases, it's like some scripts, not like programs, but sometimes still I see the advantages of the objects, classes. But let's now to switch gear to a namespace first. We will cover some namespaces, and then we will occasionally go to classes. I am not sure that we will cover classes today, but anyway, because we need to understand something about namespace and scopes. Then I will switch to classes. I will provide some points that I have in my mind about why they can be nice. Yeah. So namespaces and scopes. It's very important for us to understand how Python deals with different names when it faces with some. So right now we can create variables, right? We can create a variable, assign the name to it, and Python has different scopes, namespaces that can be accessed. I'll create a namespace.py just like to provide you some idea. Here we can see that the namespace in Python, it's some mapping structure between the object name and the object itself. We can think about it as a dictionary, just like as a representation. That this structure could be stored in a dictionary format. But the idea is that we will allocate some memory inside of the memory, and our objects, they are stored inside of the memory, right? And we usually access them by using the name that we assign to this object. And name is just a variable. And we need to know how Python resolves this in the way that it knows that, okay, this name refer to particular object in the memory. Yeah. So in case if we created a list 1, 2, 3, we allocated some memory inside of the our computer, and then we are saying, okay, let's create an object. Object was created, and now I want to assign the name for this object. And in our case, we assigned X to the list 1, 2, 3. And now, yeah, so if we write, for example, print of our variable, Python knows that there is a name X and what corresponds to this name. And then there is another concept of scopes, and different scopes they have different namespaces. This is an example of the first scope that we will see. So whenever we create a function, we have a local scope where we have a namespace inside of this scope with particular names that were created inside of this scope. So you can see here we have an example that we define the function local scope example, and inside of local scope example we have the local variable that we created. You can see it's not like somewhere outside. So we created a local variable, assigned the I am local. Yeah, so we assigned the variable. We inside of the function we use the print statement. Now let's execute the program, and you can see when we call the function, we got that I'm a local just as a print of our function. But now let's try to access this variable, right, outside of the function. Let's write print local variable. And you can see right away my editor saying that there is a mistake because local variable is not defined. Why it works in this way? Because we have our main scope, which is like when we are outside of any function, when we are just like in a plain file, it's our main scope. And inside of this scope, we did not specify the variable local variable. And now if I try to execute it, I'll get a name error inside of the output of our program. And it's saying that local variable is not defined. And this is the idea of that we can have different scopes inside of the Python. Yeah, I'll just cover all of them. Let's take a look on the enclosing scope. This is a little bit more comprehensive example probably. So let's say that we have a function, and inside of one function we specified another one. Sometimes it could be useful. Here we have an example. We specified the outer function, and there is the outer variable. So we specified variable in the body of the first function, outer function. And the variable is I'm in the outer function. Now no one says that we cannot define a function inside of the function. So let's create a new function. We will call it inner function. And inside of the inner function, we have the inner variable. I am in the inner function. And then we are trying to print outer variable, inner variable. And then we call inner function inside of the outer function. And then we just like in our global or main scope, we call the outer function. So guys, any ideas? Will it work or will it fail? So why I'm saying like will it work or no? Here we have like a tricky part. So we are using outer variable, right? But we did not specify outer variable inside of the inner variable. It's like outside. So what do you think? Will it work or no? Just like, I mean, idea, it doesn't matter. If you wrong, it's okay. I just want like to hear your voices, you know, because I'm sitting here alone. No one talks to me. Before, lessons were like held offline. I could see people, they were like doing something. Nowadays, it's like I barely see you. So there are just like two people who supports me in my journey. Okay, any ideas, guys? So we have some message. Okay, some message. It's like it's a rule that we will cover. Okay, but no one wants to share his or her opinion, right? Beside that. Okay, I'll say myself. It will work. It will work, guys. But let's just execute it. Okay, it works. Probably I had like some spoiler knowledge before, but it works. We can comment this part. Yeah, so we got I'm in the outer function, I'm in the inner function, and it works. This scope, which is like outer relative to the inner function, is called enclosing scope because it's the encloses other function. And yeah, so this is an example of the global scope. Let's also cover this part very briefly, very fast. And then we will try to understand the concept, how it works in Python, how Python handles everything. In this case, we will create a global variable. I call it global because it's in a global scope. We assign the I'm global, and then there is a def global scope example, just a function. You can call it in any other way. But here I just want to show you that Python can access global scope inside of some local scopes. And you can see here we are like saying like print global variable, and it will work. Yeah. So, and it works. And now also one more scope, which is called like built-in scope. You saw, and I saw it before, that there are some names that by default provided by Python, such as print, len, sum, representation, max, min. All of these functions, they are in built-in scope. Because of that, we can access them in our program. Python knows what does each name mean and where the corresponding object is. And this is a representation of the rule that Dastan sent to the chat, that Python have particular structure of the way how it tries to resolve the corresponding pair name and the value. So this is a like hierarchical structure. So we have built in, it's like accessible in any place of our program. Then a little bit less, it's a global scope. So if you specify anything inside of the file, if you're like not inside of the function, not inside of the class that we will see a little bit later, it's a global scope. And if you specify the variable or object inside of this scope, you can then later access it inside of the local scopes of your functions. So yeah, here we have the example of outer function, and everything that you specify here will be enclosing scope for the next inner function. And this one, you can call it as a local in case if you are here. It could be like much more complicated structure. You could have like nested functions, but this is just a rule which stands like so. It's like LEGB rule, and the idea is that you use it when you need to resolve and find the variable inside of the scope. So local, enclosing, global, built-in. And here I just tried to represent the idea and also to highlight why it's nice to have such concept in the programming. So let's say that you are like inside of your room, and right now like this room is your local scope. And now you want to find TV. So let's say that you are trying to find TV. And how it works. So you are like inside of your room, you are trying to find it, and I hope that there is no TV. Yeah, you have like some laptops. Very nice room. You want to find TV, okay. I did not find it in local. Then you're going to like another room. There is the enclosing, so it's like you can think about it as enclosing scope. You're trying to, so Python is like trying to find the TV there. It's like, okay, there is no TV. You went to another room, again no TV, but bam, you went to built-in and you found the TV. Also, what can we take from this example? So you can see that in closing you have a laptop, right? And let's say that you have a name for your laptop. I don't know. You can call your laptop as a, I don't know, my bro. Let's say that you call your laptop bro, right? And you're like starting from the first room, and you're like, okay, I want to find bro. And here you have like two bros inside of your room, like this one and this one. Not very nice example, but the idea is that you can specify the same name in different scopes, and they will refer to different objects. So if you do it inside of the local scope, you can say, okay, I create a new variable with the same name. And in this case, you have more flexibility that you don't need to use over and over again new names. It's just as an example. Usually better to have like very explicit and understandable variable name for your object, but you can think about it that you could have the same names in different scopes, and in this case it provides you opportunity to reuse the same. For example, you specified X in the global scope, and then you can do it inside of the local scope. You can say, okay, now I want to create X and have something else. So, okay, guys, this was an example, and now we can interact with namespaces. For that, there are different functions, basically 3 of them that we will cover. There is a function globals, there is a function locals, and there is a function dir. And let's just take a look on all of them. So I'll create a new file, interact with namespaces. .py. Let's put the example. Here we have global variable. We created a variable inside of the global scope. And then we have the function we define check globals. And inside of this function, we only print result of the globals function. And then we call the check globals. And here you got the following output. So we got, as a result of the globals function, we have the dictionary, as I said. So this structure can be represented as a dictionary, and Python uses it to highlight it to us. So, and then there are different things which are in the global scope. So in global scope, we have name, and name corresponds to main. As you remember, at some moment we were covering modules, packages, and we could use name, check it. We were checking that it's equal to main. Then you have doc, which is none. You have package, it's none. Loader, all other like technical things. Basically, we have built-ins. As you can see, so built-ins is a module, and it's accessible inside of the global scope. So built-ins is a module. Also, we have the file. So file is basically the file that we opened. Cache, and here we have our little friend. So it's the global variable. So this one is a variable that we created. So global variable, I'm global, the value of it. And then there is also check globals function that we defined. And you can see, so it's also inside of the global scope. And this is an example that you can check the global scope. Then you can do the following one. So you can check, now we know that there is a built-ins in the scope. So let's just print it. So we print it, and this is a module, right? And now I will just switch right away to the dir function. So dir function, by default, you can use it here. Let's say that you print dir. And print dir, you can see what it does. So it just provides us the names. So here we have the pairs, right? Name and the value. But in this case, we got just names. So dir function gives us only the names. But what is beautiful, that we can pass any object to the dir function, and it will give us all names that are inside of the object. It could be like local scope, any type of scope. Let's just provide built-ins to the dir function, and let's execute it. So, and now you see it. So this is all things which are like implemented or specified in built-ins module. And since, as I showed you before, it's by default attached to any file that we have in Python when we execute it, it provides us opportunity to use any function which is specified in built-in module. And you can see here that, for example, there are some examples that we already saw. Type, tuple, that we can create a tuple using tuple function. There is a method sum, method str, sorted, slice, print, power, all of them, they're like in built-in, and it's not a magic why we can use them. They are like indeed specified in this particular module, which attached to any file that you're trying to execute using Python function. So very nice. Now there is also locals function. I'll comment this part. And now we can check locals. In this case, you have local variable, I am local, and you need to use locals function. Yeah, so it's just like as a warning that I specified variable, but I didn't use it inside of the function. And usually it's in case if you would not use a locals function, it would be strange that you have a variable that we never used in the program. Usually such variables should be omitted. But here is an example that we can use locals function to get the names which are like in the local scope. So that's it about the scopes. You can play around with it more to find different tricky examples. But the idea is that you now we got like a grasp about how Python tries to resolve these things and tries to find names and objects in our programs. But now let's switch to the classes, and I'll try to tell you about why they are nice, even though I'm not using them all the time, right? But the idea is that, so now we have in our program, we can specify, for example, numbers, right? We can specify numbers, we can specify strings, we can specify Boolean data type, some like basic data types we can utilize in our programs. And let's say that now we want to have a function, and this function takes the object and performs some operation. And let's say that our object is a car. So we now want to, let's say that we are trying to build a website where we want to sell our cars. And usually we need to have some information about the cars. Let's say that we have a brand, model, year, color, fuel, odometer, which like shows the distance that was traveled by the car, and the status of doors. Are they locked or no? And now let's say that we need really all of these attributes in our function to work. And in this case, we would need to specify each attribute of the car over and over again. So let's say that I have the representation of the car not as a single object, but I have like, okay, all these like variables I created for one of my car. I created brand 1, model 1, year 1, color 1, fuel 1, odometer 1, doors locked 1. Then okay, I need like to create a new car, and if I don't use classes, I need to have like brand 2, model 2, year 2, color 2, fuel 2, odometer 2, doors locked 2. And now let's say that I have a function that's supposed to print some like nice representation of the car. And in this case, I need like to pass all my variables to the function, and then function will do something. So it's just like a naive example, but just like to cover the idea that sometimes we want to create a solid structure which encompasses a lot of different attributes and also a lot of different methods that we can utilize, and it's supposed to simplify and provide us the way how we can specify the structure that we can then reutilize in our program with the idea of decreasing number of lines that we want to write. And this is an example of the syntax in case if we want to specify our own data type in programming, we need to use classes inside of the Python. So, and this is an example of the syntax. If you want to create a new data type, you need to put class, specify the name of your class. In our case, it's a car. You can create a class and call it, for example, the DNA, something like that. And then you have the initializing method, which is called init. The important part that it should be in the same way called. So double underscore in the front of the init and double underscore in the, like as a trailing part of our name. Then there is a self. This is also so important part that the first argument, it refers to the object itself. This is very tricky part usually to explain for me somehow, but I'll try to make it clear. This is just as an example of the syntax now. I'll copy and then I'll try to explain what does self mean and all of these things also. So let's just create a new file. I'll call it car class.py. So, and here we have our car class. And you can see we have init, self, brand, and all of these things. Now, what can we do with that? We can create our own instances of the class. To do this, we need to use the following syntax. So let's say that I want to create a Camry in the same way as it is in the example. So I want to create a Camry, and in this case, you can see we need to put the following thing. So we use car now, this like name, as a function some way, and we need to provide brand, model, year, color. And as you can see here, we specified some default values for fuel, for odometer, and for doors status. And you can see that we did not put the self. Why we did not put self? Because when we have this call, self will be Camry. So the Camry will be, this like it works as a Camry stands for self, and now we will add all of these attributes to the Camry object. Now, after that, we can print Camry, and in case if you want to access to particular attribute of your object, you need to put dot, and this part we already saw. Why, for example, strings, why when we worked with strings, we were like, okay, we have some string, I want to get it like to uppercase, right? I put dot and then like upper to upper, like lower to lower. And then, so this is because the strings, it's a class that implemented in Python. And when we create a new instances, a new string objects, they will have all this functionality which is specified in the like a parent class. And now we can get the access to the brand, let's say, or like print Camry dot here, Let's run it, and you can see, so yeah, we created Toyota Camry, and then there is a year of the car. Also, we can create a Tesla, doesn't matter. Then there is example that we can access all this functionality. And now here I'm trying to explain about the init method, because I don't know, so for me somehow it's tricky to explain this part about the self in front. So, and this the explanation that I have. So yeah, it's like a placeholder that refers to the instance of the object that we are working with. So when we are trying to create an object by using this syntax car, we have a, let's say, like as a template, some like placeholder. It's empty object, and then we add to this object different features. So here we added to this like a template, we added the brand, and we assigned as a brand here the brand that was passed from outside. And in general, you can, the names could be different here, for example. So let's say that it's like input, like input brand, input model, input year. Like just to make it a little bit more explicit that these names could be different. I will keep a fuel odometer doors locked in the same way, but that here we just need to now put the correct ways, correct names. So in Pierre, and then also for color. Just like to make it a little bit more clear. And then if we are using the names inside of our constructor, I will put also the same names here. I just made it a little bit more explicit that the brand on the left, it's not a rule that it should be the same name on the right. So this is just our function arguments. We already know about function arguments. We can put any names here. In general, also self could be different. You can call it in any other way, but it's better to use self, because in this case, it's like as a convention in Python that all classes, usually they use self as a name for the first argument. Here I just like tried to make it more explicit that it's not strict, that the left part should have the same name as the right one. So this is a input argument that we provide when we are trying to create a new object. And then in our template, which is like an empty object, we created a new attribute by using self.brand, and we assigned to this brand something that was given by the input. I hope that it's a little bit more clear. Yeah, and then so it's a object, and here we then, when we are trying to use car something, Python passes Camry as the self argument to the init, kinda. And then you can see about, you can think about it. So this is our features that we specified, and then self. So we assemble a new object. So from the scratch, we created a new object. So this is a Toyota Camry 2023, red, 100% of the fuel is there. Odometer is 0. Yeah. Guys, now question to you. So if it's not clear, please say something. Is it okay? So I mean, like the point that self, usually you can think about this method that, okay, self, you create self as a empty something in this particular case, and then you just assign or add some like features to this object, and then in the end you just return it as a result. Okay. Now we can implement our own functions inside of the class, which is like very nice. Now we can implement some functions, and then we will be able to use them in the same way as we did it with strings, lists, tuples, dictionaries, all of them. So now we are like also capable to do that. I'll just remove all of this. I'll copy paste this part. So this part is the same. So this is just initializer of our objects. And then we have, so for example, vehicle status. And here we have only one argument self. And then we only using the brand, model, year of this self object to print some nice representation of the object. Also, we implemented the method unlock. As you can see, also here we provide self, and self, it's basically this. After we created the object, it's not like an empty object. It contains all features that we specified, and later on in all other like places, in case if we use the method, we will get the features that are inside of the object. So unlock, lock, and let's just create a car, and let's just use all of this functionality. So we created a car, and brand is Toyota Camry, everything the same. And now let's just use the method that we implemented by using the syntax that we saw many times before, but now we can implement it ourselves. So vehicle status, and you can see here we used the method, but we did not pass any argument, because by default the self will be the Camry. So you can think about it as you pass it as a self, and then you get the details from this object. And then we using the unlock method. So you can see car status, and we got a very nice representation of our car. Yeah, okay, never mind. So we got a very nice representation of our car. And we can see the doors are locked by default. And then we used the method unlock, and we can get the Camry status one more time. So let's do it in this way. So now if I run it, you can see that the doors status changed, because this is the attribute of inside of our object. We changed it, and now doors unlocked. Yeah, this is the same. Yeah, this is the idea that class, when we create a class, you can think about it as a factory, and then this factory can create a lot of different objects. In our case, objects are instances. So it could be, for example, F1 car, or just like some general, I don't know, cars like as a crossovers, or I don't know, some truck. And yeah, let's just create one more example in the same way that we had before. Tesla X. Where is the Tesla? So we will create Tesla X. And now in the same way we can get Tesla X vehicle status. And you can see, so it works in the same way. We just like once implemented the method for the objects that we have, and then we can use it with any object that we have in our program. So now we have status Tesla Model X 2023 and so on. Yeah, you can create an attribute which will be shared with all objects. There are usually some examples about when it can be tricky and misleading, but here I'm trying to provide the idea that, let's say that we can know about location of the car where it was assembled. So let's say that we know that this car was assembled on particular factory, and this feature should be shared with all instances, with all cars that were created on particular factory. And in the same way, in class we can put some variable which is inside of the local scope of the car, not inside of any function, and then any function will have this feature. So vim shared attribute .py. So here we have class car, and I added factory location. We created the two cars, and factory location is the same. Now let's try to mess with it. So let's say that I want to change Camry factory location is 1, 2, 3, and let's just check how it works. You can see, so in this case we changed just in one particular case, but you will see that it's very tricky in case if you have a mutable object inside of the shared location. So let's say that we have factory location not as a string but some mutable object, and this is a 51 and 10, so it's like as a location. I'll comment this part, and now in case if I change it, so let's say that I want to change only for the first car and say that it's let's say that I want to change like the first like coordinate to the 10 too. And now you can see that it's like lead us to the same behavior that we saw before with the function and lists, that since this is a mutable object, it's shared with all instances. In case if we change just like inside of one object the coordinate, it will change in all of them. So you should keep it in mind. Okay, so guys, I think that I will stop here. We will cover magic methods later with inheritance. So that's it for today. If you have any questions, then feel free to ask. And also, so we need to find a time, like a convenient time to get one more lesson, because one was missed. On Thursday I was out of town, so we need to find an option for that. But beside that, that's it. So